Okay, so things that are in brackets, big square brackets like this and like this, you don't have to take any notes on. These are just things you want to know or things which are review. So the last time we talked about the Bohr model, and the Bohr model said that electrons could only be found or reside in orbitals and orbits rather, and they are fixed paths around the atom. And that was called the planetary model. It's like I can go upstairs one at a time or two at a time, but I can't float in between the stairs. That's what Bohr said about electrons. And this model served to explain the line spectrum of hydrogen. But it didn't work for any other elements. So along comes what your book calls in section 2.6, the quantum hypothesis. This is where you need to start taking notes to turn in for points, the quantum hypothesis. That's supposed to be an E, not an O. Okay, and the idea of the quantization of energy was developed by a man named Max Planck. So Max Planck determined that all forms of energy existed in individual little packets that he called quanta. Q-U-A-N-T-A. Knowing what a quantum is important. Quantum is singular, quanta is plural. This meant that light wasn't just a continuous stream of particles, but individual little bits. And a quanta of light, see quanta being singular as opposed to, quantum. Q-U-N-T-U-M. Quantum of light is called a photon. So like photon torpedoes and stuff, photon's a real word. Okay, so we could talk about a quantum of light, but everybody calls them photons. And this leads to something that is not mentioned in your book. This is important. This is like a Jeopardy question. Well, not Jeopardy for your game, but Jeopardy on TV. Light, the light you see, all kinds of light, the whole entire electromagnetic spectrum, has a dual nature. And what a dual nature means is it acts in two different ways. It travels through space as a wave. Remember we saw that video with the little squeaky guy about waves? Yeah. So light travels through space as a wave, but it interacts with matter as a particle. So when light is absorbed by a piece of matter, it's absorbed one photon at a time. Not 2 or not 20, but 1 at a time. If one photon of light goes in, it will give extra energy to one electron, and then one electron, to lose that energy, emits one photon of light. So it's one photon at a time. And then your book goes back to Bohr. Okay? Oh, okay. The book says that an electron, I'm using E negative for electron, absorbs one photon and goes to a higher energy orbit. Now, the energy of the photon depends on what orbit the electron goes to, but it's one photon in and it pops to a higher energy orbit. It wants to go back to a lower energy orbit. It has to get rid of that energy, and so the electron emits one photon of light and goes back to a lower energy level. Lower energy orbit is what that says. Okay, so this is the stuff you're taking notes on to turn in. Okay, if you look at page 226 on page 213 of your text, this is important. Okay, this is 226 on figure 226 on page 319. This is Bohr's planetary model of the atom, where he has the nucleus in the center and the n equals 1 orbit, the n equals 2, the n equals 3, the n equals 4 orbit, and the electron can go into any of these. N goes to infinity. Claymore, please move. Claymore says hello. So your textbook labels these orbits. N equals 1. They stop at n equals 4. I stopped at n equals 5. But low energy orbits are down here, n equals 1, up to higher energy orbits with a higher number. Okay, we talked about that in the previous lecture as well. And this was called the planetary model of the atom. Okay, another thing you do not have to take notes on. It's 12.8 of your book. It's only here because it's in your book, not because you really, really need it. Electrons exist as waves, not only as particles. And you only need to know that. So just as light has a dual nature, a wave and a particle nature, so do electrons. So electrons can behave like particles, which we think of them as all the time, or can behave like waves. This theory was developed by a Frenchman named Louis de Broglie. It's not de Broglie, but de Broglie. So you do not have to include this in your notes either. Okay, turn those in and we'll be back.